Speaking of Dean, yeah, we're really fortunate to have Dean tonight with us. He's very much in demand. It's a busy schedule. In fact, we wanted to try to get him last semester, but so we got him this semester, and that's great. Obviously, he's going to give us a tour of the universe. He's a renowned public speaker, author, educator, a national popularizer of astronomy, and he's an expert in observational astronomy as well. So I guess that means he knows math, I think, pretty sure. He served as the astronomer at the Cincinnati Observatory in Mount Lookout for over 20 years. Ended that in 2023. He was the astronomer in residence, selected to be the astronomer in residence at the Grand Canyon in 2021. The author of 6 books, 100 Things to See in the Night Sky, How to Teach Grown-Ups About Pluto are 2 of the titles. And from 2010 to 2019, Dean was the co-host of a nationally televised program on PBS entitled Stargazers. He's contributed to Astronomy Magazine, Sky and Telescope Magazine, Farmer's Almanac, USA Today, Science Friday, and Here and Now. He's also the host of a popular astronomy podcast, which I'd recommend you tune into, called Looking Up with Dean Regas. And he just brings the complicated field of astronomy down to earth for people of all ages, and he's going to do that tonight for us. Thank you, Dean.
Thank you. Thank you, Tom, and good evening, everybody. And it is, I think, appropriate that Tom won the book, right? I mean, Tom's the one that got me here, so that was not fixed. Hopefully, there's no public record we can look at about that. But anyway, it's my great honor to be here, talk to you about the entire universe. So I've been doing astronomy for more than 25 years. I got my start working for the Cincinnati Parks at Burnett Woods, the Trailside Nature Center. There's a little planetarium there, and that's where I learned astronomy first and just fell in love with the subject. And so I've been kind of starstruck ever since then. And in any time, it just seems like doing stargazing is my form of therapy. It's my way to get out under the stars, see things, relax a little bit. And my great aspirations are to see total eclipses and supermoons. Did anybody see the moon last night? I like to keep things simple in my life. And so this is what I do, is to see around and see what's up in the sky. And so today we're going to think really big. We're going to go out to the edge of the universe and back and show you what is out there. And so like Tom said in the introduction, maybe some of you have seen me on TV. I was co-host of the Stargazers TV show. This is on PBS. And if it was me and my buddy James Albury, we came to you every single night for about 9 years, and was on at a very convenient 1 a.m. So if you didn't see it, I'm not too hurt. But anyway, that's where they usually aired it. And so we would fly around the space and tell you what's going on in the universe. So now I do a podcast called Looking Up. So wherever you get your podcasts, check that out. It's through conjunction with Cincinnati Public Radio and WVXU. And so I interview guests from around the astronomy world. We have new episodes about every 2 weeks. So check that out wherever you get your podcasts. And I'm the author of 7 books, including 100 Things to See in the Night Sky, 1,000 Facts About Space. I have a new book called All About Orion, which is a tactile astronomy book. This is a combination Braille and tactile astronomy, so you can actually feel the outlines of the constellations. And so this is done in conjunction with our local printer, Clovernook Center for the Blind and Visually Impaired. So they're the ones. This is their first unique published book, and so it's a great honor to be working with them on that. And then my controversial How to Teach Grown-Ups About Pluto is out there as well. And so I need to test my audience here. How many of you all are still mad about what we did to Pluto? It's a few hands up. All right. So by and large, I've found over the years that the majority of kids don't care. But that the majority of adults do care for some reason. And I don't know how many times this has happened where I'd give a talk about astronomy, any different topic, could be the tour of the universe, could be 100 things to see in the night sky. Kids would come up and ask questions and then also like talk about, hey, did you hear about this new discovery? And I'm like, yeah, did you hear about this? And then in the back, you see them striding towards you with a purpose. An adult was coming up, and they might even come up and shove a kid out of the way, all to tell me Pluto's still a planet. And then they walk back away. They might even shove a kid on the way out. And I was like, whoa, this is intense. People have feelings for this little thing. And then I felt bad for the kids. So I thought, I need to write a book for the kids to help their traumatized adults. So it's a kid's book, but really sneaky for the adults. And it is illustrated, including the 5 stages of grief. Never seen a kid's book with that. I had to lobby to get that one in there. So as you can see, I have a little fun with the subject because astronomy is a fun subject. Astronomy is a big subject. It's all encompassing, and we're learning so many new things every day that it's just a dynamic subject to go in. So I'll have the books are up here at the front. At the end, you come on up, browse, check them out, and I can sell them, sign them, all that kind of stuff. And it's holiday season, right? Oh, yeah, come on up. I mean, you got the author here, so come on up. We'll check out the books at the end. But we're going to go a little bit farther. And oh yeah, that's right. And Tom mentioned this. I was at the Grand Canyon. I was their astronomer in residence, and so this was my view, basically out my window every morning. So I got to live and work at the canyon. It was one of the most remarkable experiences in my life, and I even got to do astronomy down at the bottom of the canyon where they have a telescope already, so I didn't have to carry it. That's good. And then I was just recently out there for 2 weeks doing programs with them, so I get to go back out there quite often. Such a great, amazing park, such a dark sky park where you can see the Milky Way straight overhead. It's just an amazing place. So highly encourage people to get out to dark skies and national parks and see these things. It's just incredible. So we want to get out a little bit farther, and we're going to be taking a tour of the universe. And so first little bit we have to get through is, what is the universe? Anybody like to tell me? Short. I like short definitions. Everything. Correct. One word. I like that. The universe is everything. So all the gases, all the stars, all the galaxies, everything out there. Now, this is a good idea. This is a good kind of intro, this image here that I had earlier. This is an image taken by the Hubble Space Telescope. And this will kind of hopefully get us in the mood for my theme, which, should I tell you what the theme is already? Okay. Space is really big. That'll be reoccurring over and over again. So this is a picture taken by Hubble Space Telescope. The idea from this picture is they looked at their star charts. They saw a blank area. This is an area about the size of a postage stamp, about 100 feet away. That's how small of an area we're looking at. And on the map, they had nothing. So they're like, well, we got this new telescope. Let's point this at nothing. And that's what came back. Each one of those dots is not a star. Each one is a galaxy. And a galaxy is a conglomeration of billions and billions of stars. And so in this one picture where they had nothing before, they found 5,000 galaxies. All right. What was my theme again? All right, okay, you're starting to get it. Space is really big. So this is just our little bit. This is a teeny tiny section of the entire thing. So I'm going to switch to a program that can simulate everything. It is our map of the entire universe. And so I think, I know it's getting late, but can we dim the lights, please? You guys be okay if I turn the lights out? I used to be a school teacher, so I can come where you are. I can kick chairs in case I see somebody sleeping. Plus, I have good eyesight in the dark, so I can see you guys. Let's see. We'll go a little darker here. There. There it is. All right, everybody see the screen okay? Everybody at home see the screen okay? How many people we have viewing from at home? Just out of curiosity. Hi, everybody. All right, we're going to go really far out in space here. Now, the way that this works is there's the Earth, there's the rest of the universe, and we can fly up and go anywhere we want. We're going to leave the Earth behind, blast off in a rocket, and go up above the planet. And so here we go, and we can turn around and see the entire planet. And we start in Japan because it's a Japanese program. So I could click and drag and we can look at other parts of the globe. So we have Asia over there and Europe there and Africa there. We can see where the daytime side is and the nighttime side is. So this is supposed to be tonight, where we're in darkness over here. And when we're facing away from the sun, it's nighttime. When we're facing towards the sun, it's daytime. And so this is our place in the universe, this little ball, about 8,000 miles across. Now, I can also move our time forward, so we can go backwards and forwards in time, and so we can make the Earth rotate. So this is what we do every single day, spinning around. In Cincinnati, we're moving about 800 miles an hour or so every day. So we're kind of moving around. So if anybody says you're not doing anything, no, I'm moving pretty fast. So there's our day and our night. Now let's leave the Earth behind, and now we're going to go out to our next level. So we're going to make some stops along the way. And so what's going to be our closest thing to the Earth? The moon. All right, I like that answer. And there is the moon. So there, look how tiny the Earth is. The moon is that little speck right there, and that's the distance between the two of us. Surprising, right? I thought we were a lot closer than that. This is the scale model. So this is 240,000 miles, the average distance from the Earth to the moon, a 3-day rocket journey for Neil Armstrong and Buzz Aldrin. So they get in a rocket 3 days to get to the moon, a couple days on the moon, 3 days to get back. So I always like to ask my audience, how many of you would do that? Free round trip. Nope, you got to come back. Sorry. Unless something goes wrong, if you sabotage it, then you're not coming back. So yeah, so this is what we're looking at for future missions. It's going to be a little bit longer. They're probably going to be 10, 12 days to go to the moon and back. But that's about the journey. Now the moon is going around us. This is the moon's orbit. And so we can get our time going a little bit faster and watch the moon go around the Earth. There we go. So it takes about 1 month for the moon to go around the Earth. All the while, the Earth is spinning pretty fast in there. There we go. So we're racing into the future. We're already in 2026. Keep an eye on that. That's the other plus, is astronomers know where everything's going to be. So let's leave the Earth and moon behind, and then we'll make our next stop. As we open up our scale here, we can start to see the Earth's pathway around the sun. And we see another planet's orbit there. Anybody want to guess what that one is? Venus there. Very good. That one. Mars there. That one. Mercury there. There's the sun right there. So let's put the sun in the center. And now we have our 4 inner planets, Mercury, Venus, Earth, and Mars. And let's see them going around the sun. Here they go. And they go around the sun like that. So they all go around the sun the same direction. That's interesting. They don't go the same speed. Who's fastest? Mercury. Who's second fastest? Venus. Who's third fastest? Earth. And who's fourth fastest? Mars. Wait a second. That sounds like a pattern. And that is the pattern. Closer you are to the sun, the faster you go. Mercury takes 88 days to go around the sun. Earth takes 365, 1 a year. That's right. So every time you celebrate a birthday, it's another trip around the sun. And usually when I go talk to a school group, I say, yeah, you've been around the sun 10 times. They're like, oh, cool. And I say, your teacher's been around the sun about 95 times. And the kids, you know what they do? They're like, yeah, that's about right. That's about right. So now there's also another object on here called Ryugu. Ryugu is an asteroid, a near Earth asteroid, one of the many that come nearby the Earth. And the reason why it's singled out, it was visited by a Japanese spacecraft. Japanese program. By the way, this program is free, downloadable from the internet. It's called Mitaka. See me afterwards. I can give you all the info, but you can get this at your house and do this yourself too. It's pretty cool. So there's also one red circle here. This is a distance marker. This is 1 AU, which is short for astronomical unit. That's the average distance from the Earth to the Sun, about 93 million miles. So that's our distance to the Sun, 93 million miles or 1 AU. Okay, so if we're going to go visit a planet with people, Mercury, Venus, or Mars, who votes for Mercury? Who votes for Venus? Who votes for Mars? Okay. How come Mars is the one? Why isn't it Mercury? Well, Mercury's too close to the sun. Radiation of the sun will kill you en route. Bad. Venus is not great because of the heat and the pressure. It's 900 degrees on the planet all the time, every day, all day. And the air pressure is 93 times that of Earth. Means you will be squished and then melted. So Mars is our only shot because that's the only one where we at least won't die instantly. We got a chance, at least at Mars. That's what we're, now the only thing is, how far is it? If you wanted to fly from there to there, remember it's only 3 days to go to the moon, and we had some volunteers. To go to Mars is a 7-month one-way trip. 7 months to go from there to there. By the time you get there, you can't turn around and come home because Earth is over here. So you have to wait 1 year on Mars for the Earth to catch up and then fly 7 months back home. So round trip is 26 months. All right. So who wants to volunteer for that? It's free. No, not a lot of takers for that one. So, well, let's keep backing up here. Between Mars and Jupiter, this is this region filled with rocky and metallic objects that are circling around the sun. This is the asteroids in the asteroid belt. And this is one of the newest fields because we are discovering the asteroids every day. We're now up to about 1.3 million asteroids that have been discovered, all going around the sun, all different. And the reason why we're finding them is because we're looking for them, because we're looking for ones that are coming at us and hopefully can save us from being hit. And so I got good news. None of those 1.3 million asteroids are going to hit the Earth. Does that make you feel good? Okay. What about the ones we haven't seen yet? No, just keeping you on your toes. That's all. That's why we're keeping looking. We want to see them as much as possible. Now, we've been looking at this from the top, but space is in 3 dimensions. So let's go sideways and we'll see the solar system is very flat. All the planets are in the same disk, the same kind of lineup. Some of the asteroids are offline a little bit. This is an asteroid called Ceres, that orbit right there. And there's only one really diagonal line going through here. And did you see which one that one was? Where is it? It's down there somewhere. There it is. Oh, yeah, Pluto. Sure. Yeah, let's just keep that a planet. Yeah, why not? All right. Well, anyway, we'll get to Pluto soon enough. So backing up some more, we get to the planet Jupiter and then Saturn. So Saturn is the one that's about 10 times farther away from the Earth from the sun than the Earth is. And let's just zoom in on Saturn because it's just too cool. So Saturn has 274 known moons now, also kind of new. Titan is the biggest one, but of course Saturn's most known for the gorgeous rings that are around the planet. This gives it that view that just looks unreal in a telescope. And the rings are very wide from one side to the other, but extremely skinny. And so right now, the rings are very skinny, so it looks about like that in a telescope. So they're slowly but surely will open up over the next few years. But Saturn is one of those planets that you can't, it's just mind blowing when you see it. And right now is good Saturn season. So if you have a telescope, it's a good time to look for it. Okay, let's keep backing up. And now we get out to the planets Uranus and Neptune. So Neptune is our farthest of the planets. And they're all going around the sun too. And here we have Pluto. Now let's get them moving here. We're going to go around, we have to go 1 year at a time now to show them moving at this distance. So it takes Pluto about 248 years to go around the sun once. There it goes. Okay. So why isn't Pluto a planet anymore? Well, it's not because it's small. It is about the distance from Cincinnati to Denver. That's how big it is. It's not because its orbit is weird that it goes out farther and in here. And in fact, it's closer to the sun than Neptune for about 20 years. And I don't know about you all. I was in school between 1979 and 1999, and my teacher never told me that Pluto was closer to the sun than Neptune. Did your teacher ever tell you that? I can't believe that. Well, if you weren't in school then, sorry. Then they told you right. So it's not that. It's not because Pluto's orbit is different and tilted compared to all the other ones. It's not because Pluto's made of ices and none of the other ones are. The reason why Pluto's not a planet is because they found more stuff. So when we were kids, it was the only one we knew about out here that went around the sun. But our technology got better, and we found things like Haumea, Makemake, Eris, and maybe you could just barely detect all these other little dots that are right here that are also going around the sun. You see those little things that are just barely making them out? So astronomers found those by the thousands in the last 25 years. And so the astronomers had to get together and figure out, okay, Pluto's still a planet. What are we going to do with the thousands of other things we just found? And you know what some of them said? Make them all planets. Make them all planets. Make them all planets. And what did the kindergarten teacher say? How am I going to teach the kindergartners at 2,000 planets? It didn't make sense to include all of those things because they're different. They're different origins, different compositions, different orbits. And Pluto is one of them. And so that's why Pluto got kicked out. They didn't do it real good, and they didn't write up a real good definition, but that's what they did. And I was still mad at first because I thought, well, this, I don't know about this. Pluto was my favorite because it was kind of the weirdest one. But then I learned of a new, weirder one. It turned out Pluto wasn't so weird. It had thousands of other relatives. But then there's this thing called Sedna, which nobody talks about. It's almost as big as Pluto. Its orbit goes out 1,000 times farther away than we are. And it moves, we have to go 100 years at a time just to see it moving. So it goes slow when it's far away, fast when it's close, takes over 10,000 years to go around the sun once. That's weird. So anybody that's mad about Pluto, here is your new object. Embrace the weirdness of Sedna. Well, I know that probably didn't help much either, but let's keep backing it up. Because past here, this is where we get into a region called the Oort cloud. This is where comets live, long period comets that are circling around the sun. And so we see these comets come by from time to time. We have a couple comets in the sky at night right now. They're very faint, but they came from out here. And then some comets go out as far as 1 light year. That's the distance light travels in a year, or about 6 trillion miles from there to there. So anything coming into this circle, basically the sun is going to affect. Okay, so that's our solar system, and the sun is in the center. Well, let's check out the sun. This is holding everything in here. Everything I've showed you so far goes around the sun. So if we want to go to the next level, we got to go to the next sun or the next star. You see some in the background look familiar? Make a little shape up there in the upper right. That's the Big Dipper right there. Look at that. Each one of these is stars. Each one of these are bigger than our sun, and it's not even close how much bigger these are than the sun. And so if we want to go amongst the stars, we have to go way out again. We have to go past that 1 light year mark. And notice, even if you're out here at Pluto, the Big Dipper still looks like the Big Dipper. You're not far enough away to change the view of the stars. We'll only start to get changing once we get out light years away. It's starting to get a little weirder, but still pretty normal. And so here we are at the nearest star to us, called Alpha Centauri right here. And it's really a 3-star system, 3 suns that are circling around each other. So if you live there, you'd have 3 stars in your sky. Yeah, 3 suns, 2 yellow ones and 1 little red one. So imagine watching one sun set. You think it'll be dark? Nope, another sun comes up on the other side. And so, well, I can tell you how far away it is, but I think the best way is how long would it take you to get there? So 3 days to go to the moon, 7 months to go to Mars, 9 years to go to Pluto. To go to Alpha Centauri with the fastest spaceship we've ever made will take you a mere 74,000 years. Yes. And usually when I show that to kids, there's a kid in the audience that yells out, "I'd be dead." Yep, you'd be dead. That's right. That's correct. So that's the closest star to us. These other stars are much farther away. The Big Dipper stars are about 80 light years away. And look, now that we're out amongst the stars, we see some of the other farther ones like Pollux and Castor, Capella, Aldebaran. There's our North Star up here, Polaris. And here we are over 100 light years away. And we got to think in 3 dimensions too. So these stars are all around us. And we'll keep on going. And here's some other fainter, farther away stars like Betelgeuse and Rigel, Deneb. And so these are some of the farthest stars you can see with the naked eye. Okay. Well, let's take a little pause here for a second. How's everybody doing? How's everybody feeling? You feeling big? Mighty important? Well, I like to take a little breath here, because if you're feeling small, if you're feeling insignificant, it's going to get worse. And it's going to get worse real fast. Because these, as all of the stars that you're seeing at night, so you go outside, some of those are the stars you see out there. These are really gigantic stars. They are only a teeny tiny, itty bitty section of one spiral arm of our galaxy. And so there is our Milky Way galaxy that we live in. It's about 300 billion stars, all circling around a center of mass. Looks like a big pinwheel. And the sun is that one. 300 billion suns, and we're there. We're not even in the center. We're not even downtown. Well, what is in the center? That's where most of the stars are jam-packed. So it's hard to form planets in that area region because stars are so close to each other. But if we go right into the heart of it, we'll find a deep, dark, mysterious object of incredible density. Anything that falls into it disappears. Not even light can escape, and it warps the space and time around it. It is the black hole at the center of the galaxy. So what's amazing is that we had this artist rendering, and then a few years later, got a picture of it. Looked just like that. So what is this? This is an object. If you smash 4 million suns together, the gravity is so intense, light doesn't escape. So what goes in doesn't come out. What's going on in there? Nobody knows. A lot of speculation, a lot of science fiction written about it, but nobody knows what happens. I just recommend don't fall in. So, now luckily this is very far away from us. It's never going to hit the earth. It's never going to swallow up the sun. It is so far away that we can watch it from a great distance, a safe distance. Well, let's get back out here. And got bright there. And so we have little galaxies that are around us. Some of them circle around us, some of them are just passing through. And if you've ever been to the southern hemisphere, there's two dwarf galaxies that you can see with the naked eye. They're called Small Magellanic Cloud and Large Magellanic Cloud. We can't see them from our latitude, but other dwarf galaxies around us also. And our next major galaxy out here is called the Andromeda Galaxy, right there. And this has, well, upward of 1 trillion stars. Now, just to give you an example about this is, hundreds of billions to 1 trillion stars are shining at you, and they're outside right now. They are up in the sky. I'm not sure which direction east is, but east, that way, east, you look up there, you won't see it. 1 trillion stars, and you don't see it. That's how far away that galaxy is. If you're out at the Grand Canyon, you can just barely make it out with the naked eye. It's incredible how far these galaxies are away. So, because people say, well, how come we can't see like aliens? It's like, well, this is 1 trillion stars. Take your sun out there, multiply by 1 trillion, and we can barely see it. We're not going to see like a little guy going like this. It's not going to happen. So, let's get back to the Milky Way here if I can. It's not letting me click on it. Well, I guess we're stuck. We're stuck on Andromeda, unfortunately. Yeah, I guess we are stuck. It's like there we go. Okay. All right. So, we got one more big leap to make, and that is to show you the whole universe. We started at the Earth, we saw the moon, we saw the planets, we saw the stars, we saw the galaxy. Now we got to show you the whole universe. And, well, this could be a little unsettling. Is anybody having a sinking suspicion about the dots that are in the background? Those dots aren't stars. Those dots are all galaxies. Each one is a galaxy that we've seen, mapped, charted, and in most cases named. Each one has billions to hundreds of billions of stars in them. And so, I want to show you how many galaxies we've found so far. So here we go. Backing it all the way up. Hold on to your seats. And there we are. The entire universe. All in one little dot. Whew. That's hard to take, isn't it? Okay. You want the good news or the bad news? Good news first. Look at where you are. In the center. Yes. We're in the center. Isn't that good? Well, yeah, that's well, the problem is if the universe is everything, then it goes on forever in every direction. And so wherever you are is the center. Wherever you go is the center. They're in the center also. Doesn't help much, does it? This colorful stuff is not galaxies. This colorful stuff is the leftover heat from the creation of the whole universe, from the Big Bang. It's the farthest stuff we can detect, farthest energy. And so this is it. Outside of this, I don't know. Could be something. Could be another universe. Could be nothing. Could be it. We can't fly to that part. We can't see past that part because there is nothing there and never has been, and there's no time there. All right. How late is it? You guys up for a deep thought? This is going to be pretty deep. Okay. So there is a real reason why we can't see past this. And it is not because it's too far away. Whenever we look in space, we're looking back in time. So it takes time for light to go from one place to the other. The sunlight takes 8 minutes to get from the sun to your eyes. So when you look at the sun, that's how the sun was 8 minutes ago. When you look at stars, that's where they were years ago. The light's taken years to get to your eyes. We can't see past this because this is before time. There was nothing because the universe wasn't created yet. Yeah. Yep. Anyway, now this is the part where I also say anything that I can tell you about the entire universe makes no sense to me. When I want to show you what infinity looks like and I show you this, you're like, well, that's not infinity. Right. Is there more? I don't know. How did we get there? How could we see all the way to the edge of the universe and the beginning of yours at the same time? I don't know. Where did this all come from? I don't know. And so my famous conversation that I have with cosmologists, these are people that study the entirety of the universe and the beginning and the end. There's this real, when I finally realized they have no idea what they're talking about, this is what happened. Because maybe some of you heard that the universe is expanding, that these galaxies are moving away from each other and the whole universe is expanding. So my conversation with a cosmologist goes like this. I say, the universe is everything, right? And they say, yes. And I say, and the universe is expanding, right? And they say, yes. And I was like, how can it already have been everything and infinite and still expanding? And they say, yes. We are not deities. We cannot understand infinity. And so this is the best map that we can make of it. I know. So let's pause for a second. Any questions come to mind while we're at the edge of the universe here and looking at this? Deep thoughts, not so deep thoughts. Well, how cold is it? Well, so these colors here are indicating temperatures. This is called the cosmic microwave background radiation, and we're looking at the fluctuations of a few degrees Celsius. So we're talking almost absolute zero out here. These are just slightly above absolute zero. That's what we're picking up here. Yep. Yes. In the back. Oh, sorry about that. Oh, I'll repeat the question too. I can repeat the question.
So I was curious, do the scientists, can they estimate when the Big Bang, if that's what they're saying, when it occurred, like how many billion years ago or whatever from this?
Yeah. So the estimate, the question is like, is the estimate of when the Big Bang occurred? When did the whole universe get created? And the best the evidence is pointing to in multiple different directions from different directions to an age of about 13.8 billion years ago is when this happened. So that's why the edge of the universe, the farthest things we can see, are 13.8 billion light years away. So that is the estimated age. Now, what kind of certainty do we have in that? I don't know. These are smarter people than me that have figured this out. But there's lots of different lines of evidence that are pointing to that around that date. Okay, go ahead.
Okay, so are you starting to take questions now, or just a quick?
These are the quick questions. These are quick
Okay,
but big
okay.
questions.
Okay, so here's a fun one. So I don't understand space time, but apparently it can be folded. And I've heard some speculation, even a little bit of science fiction about time travel if space is folded. Can you?
Sure, yeah. So can you travel through time? Can you travel through space faster than the speed of light? That kind of thing. Can you fly through things at warp speed like in Star Trek? Right now, we have no way of being able to figure out how to do any of that. There is definitely the speed of light is a limit that we cannot break with our current technology, not even close, because when you go faster and faster and faster, that object basically, it takes more and more energy to move it. You become more massive as you're traveling faster. So when you get to almost the speed of light, there's not enough energy in the whole universe to move you over that. So we can't go faster than the speed of light unless we can figure out how to break that law. And, maybe give us a couple million years, we might be able to figure that out. One of the quicker ways that we're thinking of is, well, let's say space and time are all relative because, well, that's not really what the universe looks like. That's just what it looks like from our perspective in the center. So what if you lived somewhere else? Your reality would be quite different. Your map of the universe would be quite different. And so that's what space and time is. It's you are in a different space at a different time. The universe will be different. So if you want to go across the universe, you take the space and you bend it. And then you take, if you have your fingers this far apart, just bend space and bring the two fingers closer together. How much energy would that take? A lot. And then you just go from one place to the other. So it's kind of like the wormhole theory. And all of this is, it's great science fiction. There's no science fact to it that we can figure out.
Here's a question right here.
Okay.
Yes, they talk about faster than light speed. What about inflation? Occurred after our egg.
Oh, I know. This is so faster than the speed of light. Nothing can go faster than the speed of light. But let's say you have one star moving this way at 0.6 the speed of light, and you have another star moving that way at 0.6 the speed of light. Now they're going away from each other faster than the speed of light. What happens then? If you're by the one star and you look back at the other star, it's gone. You will not see it because it's going faster than the speed of light. The light's not going to come to you. And so it will disappear. So could there be things out there that have disappeared because they've gone faster than that? And as the universe is expanding, things are getting farther away. They're moving farther away from us. Could they disappear? Yes. Will we ever know it? No, because it's gone. This is why this is the most frustrating field.
Here's a question right.
To think about, though. Okay, go ahead.
Question right here.
So you're saying we're the center of the universe. So yeah.
No, I'm the center of the universe.
So,
no, you're the center of the universe.
So that 8 right there in 13.8, if we're the point between the 2, the 3 and the 8, there's a star, let's say we're sitting right on it.
Yeah.
And we look towards away from our current where Earth is, out where the arrow is right there.
Right.
Is there anything out there?
See, you're not going to like this answer either. That's the thing is I'm going to give you terrible answers. Well, the problem with this map is that star isn't there anymore. That's where that star was 13 billion years ago. Like, that's what it looks like to us. So we go to that star, it's not there. It's already been gone for 13 billion years in its own other direction. And so it's all the way out here. And so you can't say, like, I'm going to go there because there's not there. And if you could go there, then you'll be in the center again, and all the rest of it will just be around you. And you'll look back to where the sun was, and it'll be like, sun's not there. Because it wasn't made yet. I know, it doesn't make any sense, does it? I'm at least admitting to you it doesn't make any sense. The other astronomers won't because they think it does, but it doesn't.
Here's the question right here.
Okay.
That kind of leads into my question is if like a star is 10 light years away from where we are and that star dies, does that light still emit for 10 years? Like, do we still see that light for 10 years?
Yeah. So if a star is 10 light years away, it suddenly dies, we won't know for 10 years until the light stops. And so that's the most famous one. There's a star out here called Betelgeuse that makes the news quite often because Betelgeuse is a red supergiant. It's going to explode into a supernova any day. And sometimes the media gets an astronomer to say maybe it already did. And we don't know. And the reporter's always like, whoa, that's cool. I'm going to write about that. Astronomer says Betelgeuse already exploded. We don't know. Like, that's not what they said, but okay. And so, yeah, we won't know for 600 years until the star explodes, if it already exploded. So that means you could go outside and you could see it explode any day. And do we know when it will? No. When will we know? When we see it. When's that? We don't know. That doesn't make a very good news story. So that's why the reporters write it up differently, but that's how I would write it. So, yeah.
Dean, is the evidence that there was a big bang, is it simply that we're expanding, that we know we're expanding the universe?
So yeah, is it because we're expanding? No, it's mostly because of the stuff we're detecting. This outside stuff was really the linchpin behind it, that this non-uniform energy really goes to this model of this one moment that things moved away from it. There's definitely that idea that almost every galaxy is moving away from us. And so the only galaxy that's headed towards us that's a major one is the Andromeda galaxy. That's because we're too close together. So yeah, there's lots of lines of evidence for this. Not exactly my field of expertise, so I can't say much more than what I said, unfortunately. Okay, so it's getting cold out here. Let's fly you back home. And we will get to the one question maybe you're nervous about asking, but I'll get to that in a second. Let's go target the Earth, and I'll fly us back home really fast. Hold on to your seats. Here we go. Through the galaxy, through the Milky Way, through the stars, through the planets, and back to the Earth and the moon. And quite a journey to the edge of the universe and back. I got you home a little late. I was going to talk for about 45 minutes, but it's apparently November 29th, 46,184. So I did go over just a little bit. Sorry about that, guys. Earth's still there, though. That's good. Now, so, yeah, why do I show you this program? Why, I don't know. Why do I think this is such a cool thing? I think number one, getting the perspective. This is something astronomers have. They have this different kind of universal perspective on things. It makes us, because some people are like, well, it gets people depressed. And like, some people have asked, like, how do I deal with the depression of this? And I'm like, well, I don't know. It doesn't bother me that we're little teeny tiny things. I kind of like it that we're little small things. Cause I also think, well, we're pretty small, but we're pretty smart. I mean, we made a whole map of the whole universe. That's pretty good. And we're adding to this map every single day. This is kind of our legacy is, humans were explorers, we're curious creatures. This is how we got to where we are being scientific people. And so, this is just our latest trying to make sense of the universe. And I love it. I get to learn something new every day. I'm like a big kid with this kind of stuff. I should say little kid, some little thing. So this is what I think it really kind of opens up your worldview a little bit. It also kind of, when you see these pictures taken by NASA missions of the Earth and it's 1 pixel wide, and it just makes you think like, in the scheme of things, let's just appreciate our perch from right here because this is it. This is all we got. And I hate to tell you, those ideas of us going somewhere else, that ain't going to happen. We're going to set up a base on the moon. Not a great spot. We're going to go to Mars. I'd rather be here because there's no place out there that we can go and not die instantly, horribly, and painfully. This is it. And so it makes me appreciate the Earth a whole lot more as well. So I will go with 2 things here. How are we doing on time? Everybody doing okay? I would like to answer maybe the question that some of you may be nervous to ask. Is anybody thinking about aliens? You just didn't want to ask, did you? It was very, very polite of you. You didn't want, no, you can ask me the alien question. This is what I get all the time is, do I think there are aliens out there? Do I think we're the only ones in the universe? And so I cannot actually answer that scientifically because we don't know enough about our situation. How rare is the Earth? Now, when people ask about the scale of the universe, does the vastness of the universe bother me? And I say no. But the thing that does bother me is time. I don't like time stuff because where we are now is at the end of time. We've had infinite number of eons before us that brought us to this moment. Infinite number of things in the past could have been different and changed where we are right now. I don't like thinking about that. I don't like thinking about the rock that killed the dinosaurs if that never happened. Because I probably wouldn't be here talking to you right now. I probably wouldn't be giving you this presentation. If anything changed in the past, I don't like that. And just to think of all those things that happened. So we don't know if the Earth is uniquely rare. Are we 1 in a million, 1 in a billion, 1 in a trillion? And there's no way for us to say what that is. So scientifically, I have to tell you, we have no idea if there's aliens out there. But the human in me says, come on. Did you see all those galaxies I just showed you? There's got to be a planet out there that's like us with little things on it and everything like that, don't you think? I don't know. I talked to a lot of people. Most of the people in the field say, yeah, absolutely. Life is not that rare. It's not that tough to make life. But I don't know. We had a lot of weird stuff happen in the Earth's past. Just having that moon is a weird thing. How we got the moon, boy, don't get me started. That's a whole story. So I think there are aliens out there. I have no proof. I've never seen a UFO in my life. I've been watching the sky for 25 years. I probably watch the sky more than anybody else in the tri-state. And I've never seen an alien, never seen a UFO. I've seen people bring me pictures, videos, and they're all nothing. And yet people believe. I've seen the videos from the Navy pilots. Those are nothing. I've seen the alien autopsies. Those are nothing. I've been to Roswell and I've been to Area 51. Those are nothing. But it's fun to think about, isn't it? And people love thinking about it. That's for sure. Oh, I do want to test your guys' knowledge of alien lore because aliens of famously. Oh, I forgot. I have my Roswell Astronomy Club T-shirt on. I went to Roswell to see. They have an astronomy club, and they dress like aliens and everything. It's a very weird city. And so I want to see if you guys know your alien folklore, because there is an Ohio connection. So the legend is a UFO crashed in Roswell, New Mexico in the desert in 1947. The government came in to collect everything, to tell the people they didn't see aliens, and they collected the alien dead bodies from the spacecraft. And they transported the alien bodies to. Are you serious? You know this? Why isn't the government stopping you? If anybody didn't hear, several people in the room said Wright Patterson. What a secret they're keeping from us, that nobody knows where the alien bodies are. I just think it's fascinating. Isn't that kind of fun? Anyway, I love that we have a little Ohio connection. There's probably alien bodies just right up I-75. Yep. All right. Wait, I was going to say something else. Oh, right. So the other thing about this is, the other remarkable thing about our planet and our situation in the universe, what we've learned from astronomy, I think one of the most earth-shattering, mind-blowing things is where we came from, is that our sun is incredible. It is not a first-generation sun. It has gone through stuff. So I was talking about Betelgeuse. It's going to explode into a supernova. We know for a fact that our sun is not just there. It formed after a supernova explosion happened, sent the material out into space. Gravity brought it back together, formed it into another star. And we know this for a fact because we are part of it. In your bodies are the elements of supernova explosions. Heavy elements, iron in your blood, that came from a supernova explosion. Calcium in your bones came from a supernova explosion. You're wearing jewelry, you got fillings, that's where it came from. So you are superstars. Very teeny tiny ones, but still superstars. So, well, I want to thank you for having me here today. I hope you enjoyed our tour of the universe and flying around. Oh boy, that's bright. So let's see. Do we want to do a few more questions, or how are we doing on time? We can do a few more questions, I guess, if you guys like. Go ahead. You can just say it loud. I'll repeat it. Yeah. So maybe people have heard about the interstellar interloper, the interstellar object, the third one of its kind we've ever seen that's coming around the sun that came from a different sun. And of course, if it's interstellar and it's weird, it's gotta be aliens. Of course it's not aliens. It's a comet. It looks like a comet. And some astronomers have been quoted saying it's acting strangely. It's not. It's what comets all act strange. Each one, the other two comets that are in the sky, they're acting strange too, but nobody reports about them. And that they've shown these false pictures that it's elongated. That's incorrect. That's from the other one that came by a few years ago. This one's just a normal comet. Nothing strange about it. That's about it.
Let me get a mic to you. If I could get a microphone over to you real quick.
Okay.
But it's got like blue light, and they said it's missing some like iron or whatever.
Yeah, so it's got blue light, and that's pretty common for a lot of comets. In fact, the one that's up there also called Comet Lemon is also blue and green. Depends on what kind of filter you use on the telescope. So you can make it any color you want. They also, the amount of elements in it also are strange, but all comets are strange also because we only have a small limited sample size of what comets are like. And so that's why I'm really mad at the astronomers who are saying it's strange, because they're all strange. And so the reporters have decided to listen to this one strange, but ignore the other strange. So comets all are strange. And we always find things with every single comet we see that's always surprising and never before seen. But not aliens. I want to see aliens. That's the thing. I really want them to be out there, and they never call me. So go ahead. I'm sorry.
Dan, will you give us a quick review of your books there? I want to buy ones for my children who are our grandkids. So.
Okay, yeah. So the books, that'd be great. Yeah. So the 100 Things to See in the Night Sky. This is kind of like your guide to finding stars and constellations up there in the sky. Don't need a telescope, and you can even see them from most of the city locations. The Pluto one is to tell you about how planets are called and labeled, and a little bit of history of Pluto. All About Orion has the constellations, a little mythology about the Orion, and it's got a tactile feel to it also. And then 1,000 Facts About Space. You can learn a new fact every day for about 3 years. It's actually, they squeezed more than 1,000 in there, Adam A. The publisher said, can you put a few extras? Can you put a glossary in there? I was like, I already got 1,000 facts. So there's really a little bit more than 1,000. I think they got it out of me.
So Dean, what of this stuff keeps you up at night thinking about it?
Yeah, what stuff keeps me up at night? If I were to be afraid of something coming from space, I'm not afraid of the sun and sunstorms and that kind of thing. I'm not afraid of supernovas. I'm not afraid of aliens. I'm not afraid of the pole flip. I'm not afraid of comets. The only thing that could get me is an asteroid coming to hit the Earth. And the reason why I say that is because we've been hit before. There are craters all over this planet. The one in Arizona is still there, about a mile wide. That's pretty scary. They're all very old, but if history's teaching us, we're going to get hit again. So that's why I want us to keep looking for things coming at us. We're the only time in history that we can actually see something coming at us and change it. We just got to see it with enough time. How would we change it? How do we change an object coming at us? So let's give the ideal situation. We have 5-year warning. That's good. You know how much warning we've had so far? 12 hours. We saw an asteroid coming at us, super small, 12-hour warning. And we've only seen about a few before they entered our atmosphere. That's it. Luckily, they were small. They burned up. But let's say we have 5 years. 5 years, what we do is so let's say this is the asteroid. Do we go up and blow it up? No. Too much energy to blow up an asteroid. We go up and we build the biggest, heaviest spaceship we can build. Park it next to the asteroid. Let gravity do its work. The asteroid will tug on the spaceship. The spaceship will tug on the asteroid. Gravity will pull them together. You bring them together, move the spaceship out, move the spaceship out, move the spaceship out. Change the trajectory of the asteroid. All you got to do is move it just a smidgen. That expands over the 5 years, and you miss the Earth and save the planet. Can't make a movie out of that without boring. But that's the way you're going to save the Earth. If you don't have that much notice, you try blowing it up. It's probably not going to work, but might as well try it.
Let's thank our great guests for coming tonight.
Thank you very much. Thank you very much.
Thank you so much, Dean.
Thank you.